Yes, 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 come on, more power. So I did it. I was able to produce around 200 watts of power with my bicycle generator. And in case you're wondering what I'm talking about, then let me tell you that I built a bicycle power generator system with a car alternator around 2 months ago. And back then I only managed to effectively produce around 8 watts. But since there was so much feedback from my viewers with great suggestions on how to improve my system, I thought to myself, let's give it a shot. So in this video I will show you exactly how I improved my system, which includes making a spring-loaded belt tensioner, trying out a different alternator and also a washing machine motor. Let's get started! This video is sponsored by Thanks.com. In case you do not know, Thanks is a website for 3D printing enthusiasts, designers and engineers, where you can find over 2.4 million index models. I actually looked there for a specific type of pulley for this video, and ultimately even found a model that looked pretty promising. But in the end I designed my own pulley for this project, which you can actually download through Thanks and use it however you want. So feel free to join the community today and check out the awesome features Thanks offers. Now first of all, I had to reassemble my bike generator setup. And while doing so, I also made a first improvement by enlarging the holes in the iron pieces in order to be able to utilize beefier zip ties to secure the bike. And then I continued with probably the biggest improvement by switching to this time the highest gear. And I have to say thanks to everyone who commented that. And I also have to state that I'm kind of embarrassed about such a stupid mistake, because in the highest gear I was able to reach an RPM of around 5000 to 6000, which is a big difference to last time with only 1500 RPM. And that difference was immediately noticeable during the first test run, in which I popped my 21 watt light bulb at a power generation of around 50 watts. So as a replacement load I went with this big 1 ohm resistor, which at an exciter current of 1 amp heated up with a max power of around 80 watts, and with an exciter current of 2 amps it was around 40 watts. Now normally with a higher exciter current we should be able to generate more power, but the problem of my bike system is that the belt is pretty loose and thus slips. So the comment section suggested that I should create a belt tensioner. To do that I firstly took a couple of measurements and then came up with this simple sketch. My idea is that the belt will move over a kind of roller which is suspended in the air through springs. And these springs will obviously apply a force to the belt that will keep it under tension. With that simple plan in mind, I firstly designed the roller in Fusion 360 and then 3D printed it with my Prusa 3D printer. While that was going on, I created a 23 and 20 cm long piece from common 24 by 48 roof batten, onto which I marked 3 holes for fixed aluminum rods and 1 slit for moving rods. After then creating all the holes with a drill, as well as the slit with a jigsaw, I cut 2 10 cm long pieces from an 8 mm thick aluminum rods and continued by removing the supporting material of the 3D printed roller. As soon as that was done, I hammered the 2 mandatory ball bearings into it and checked whether the rods would fit, which it of course did. So I mounted the wood lathes left and right next to the belt with the help of screws and metal brackets, and then secured the roller, rods and springs into place. And as you can see, the belt tensioner does kind of work, but while doing a few tests the belt kept slipping off of it. The solution for this problem was to secure the zip ties in another way, and repositioning the alternator, as well as moving the front wheel holding construction. The last problem was that the rods would move over time, but to fix that, all I had to do was to add a thin cork barrier. And just like that, the belt tensioner works acceptably well. And while it did not improve the power output at an exciter current of 1 amp, it certainly bumped up the output power at 2 amps to a maximum of around 200 watts. Awesome! Of course, I also tried 3 amps as the exciter current, but that required so much force to pedal that I did not reach a decent speed, and I was also afraid that something would break. And in case you're wondering whether you can charge up a battery, then the answer is yes, that works without a problem. Now, even though the system was not half bad at this point, I was kind of irritated by the exciter current situation, since you never know what is the best current. So, the comment section suggested that I should have a look at a 1-wire alternator, which obviously should not come with such a problem. And needless to say, I hope that I got myself such an alternator, because this one only comes with a B+ and D+ terminal. B+ connects to the battery plus terminal, while D+ will supposedly get pulled to 12 volts as soon as the alternator outputs 12 volts, and thus does not need to get connected. Well, we will find out about that. But before that, I had to mount the alternator to my system. As soon as that was done, I hooked up my multimeter to the battery output terminal of it in order to see what voltage it outputs. And as you can see, it generates pretty much nothing. So next, I tried hooking up the battery to maybe power the exciter coil in the alternator, and thus getting it to output something. But as you can see once again, the alternator did not feel like working with me. Now the solution for this problem was such a small 2-watt light bulb, which I connected between D+ and B+. This bulb apparently limits the initial current for the exciter coil. And as soon as the alternator outputs enough power, this D+ pin should get pulled to 12 volts, and thus the light turns off, since no current flows through it anymore. And as you can see in my practical tests, this theory seems to be correct. But now the problem is that the exciter current tries to regulate itself, and thus it makes it impossible for me to pedal at a constant rate. So in a nutshell, this kind of alternator is just as bad as my original one before I modified it. So let's move on to the last comment suggestion, which says that I should try out a washing machine motor. And of course, I got a washing machine motor laying around, which I actually used in an old video to wind my Tesla coil. By simply powering 2 of its wires with a DC voltage, it starts to spin just fine, which means there must be permanent magnets inside this thing, right? Well, sadly no. As you can see, we got a stator that is a big coil and a rotor that is also a big coil. Such a motor is called a universal motor. Its stator exciter coil can be accessed from the outside, as well as its rotor windings through carbon brushes. And by simply connecting the stator and rotor in series, the motor can be powered with a DC voltage as well as with an AC voltage, which is why it is called universal. And fun fact, the created rotation through only powering the rotor did only work because of the residual magnetism of the stator. But anyway, by powering the exciter coil just like we did with the alternator, we should be able to generate an output voltage at the rotor, which as you can see is true. So let's design a fitting pulley for the motor in Fusion 360, 3D print it and hammer it into position in order to strap this motor to my bicycle system to find out what it is capable of outputting. Now at an exciter current of 1 amp, I produced around 3.5 watts of power, at 2 amps 15 watts, at 3 amps 33 watts, at 4 amps 55 watts, and at 5 amps 75 watts. at which point it was also impossible to reach a decent speed anymore. So it seems like my original alternator was the best solution for my bike generator system. Since we can produce 200 watts with it, we can correct our calculation from last time and find out that we would have to pedal for around 1.43 years continuously in order to cover my electricity bill for a year. Which makes me truly appreciate that we have reliable electrical power around. With that being said, thanks for watching, and thanks again for all your feedback. If you liked this video, then don't forget to like, share, subscribe and hit the notification bell. Stay creative, and I will see you next time!